Hi students, MCQ number 10. Consider two uniform wires vibrating simultaneously in their fundamental nodes. The tensions, densities, lengths and diameters of the two wires are in the ratio given 8:1, 1:2, x:2y and 4:1. Separately, we will list them afterwards. Okay. If the note of the higher pitch, higher frequency, okay, has a frequency of 360 Hertz and the number of beats produced per second is 10, then the value of x:2y has to be determined. Length ratio we have to find out. So this type of problem will be very commonly asked in the NEET and the JEE and other entrance examinations. Okay, how to do this problem? What are all the given informations? We will make a list first. The ratios are given. First ratio of the tension is given. So ratio of the tension is 8:1. So tension in the first wire is to tension in the second wire is 8:1. Then their densities, density of the material of the string, ρ1 is to ρ2 is 1:2. Then the ratio of the length, L1 is to L2. This is x:y. This only we have to determine. Okay. And then the next one is diameters, thickness. The diameters are in the ratio D1 is to D2. And that is given as 4:1. What next is given? The number of beats produced per second is 10. 10 beats. So when the two wires are vibrating together, 10 beats are produced, means the difference in frequency of the two wires is what? The 10 Hertz. Is it not? So if one is having the frequency 360, means the other one should have the frequency 360 plus 10 or 360 minus 10. How to find out? That also is given indirectly. See here, the higher pitch has a frequency of 360, means that the lower pitch means what? The other frequency must be 360 minus 10. 360 minus 10. Is it not? So the lower one, okay, the lower one, lower pitch frequency, I will take it as F1. So this is equal to 360 minus 10. So that is equal to 350 Hertz. And the higher pitch is given, okay, higher. So the higher pitch is having a frequency F2 is equal to 360 Hertz. So this idea should develop in your mind, okay. 10 beats are produced. The higher pitch is 360, means naturally the lower pitch must be what? 360 minus 10. So that must be equal to 350 Hertz. So we have taken the lower pitch F1 is 350 Hertz and the higher pitch F2 is 360 Hertz. Now what is the general expression? What is the general expression for the tension? Okay, the tension in the, or in terms of tension, what is the frequency? I will write. Okay, so the frequency I will write the frequency F, okay, in terms of tension is equal to 1/2L into square root of T divided by mu. So this is the expression for what? The fundamental frequency in stretched strings. So F is the fundamental frequency, L is its length, T is the tension and mu is what? Mass per unit length. Is it not? Linear mass density. So here I will write mu is equal to mass by length. Mass by length. So now I will multiply and divide by the area of cross section of the wire. Area divided by area. Okay. So in the denominator, the length of the wire into area of cross section will give you what? Volume. So this is now equal to mass by length into area is volume into pi r square is the area of cross section. Okay. So that now this is equal to mass by volume. Mass by volume is what? Density, is it not? The mass by volume is density. So this is density into pi r square. So rho is the density. Symbol I am substituting for mass by volume is the density rho. Rho into pi into r is the radius. Okay, radius of the wire is what? D by 2, diameter by 2. So this will become d square by 4. D square by 4. So mu also is now equal to pi by 4 into rho d square. So this is pi by 4 into rho into d square. So this can be substituted in this expression mu. Therefore now I can write F is equal to 1 by 2L. Okay. So 1 by 2L into square root of T. So T divided by, in place of mu what I can substitute is pi by 4, is it not? Pi by 4. So this 4 can be taken up and this is pi rho into d square. So this is the expression. Okay. Now this 4 is inside the square root. When it is coming out, it will become 2. So this is now equal to, this is equal to 2 divided by 2L into, so into square root of T divided by, so this is T divided by pi into rho I can keep. This d square inside the square root also can be brought here, is it not? So this will become 2LD. So this 2 and 2 get cancelled. Therefore F is now equal to 1 divided by L into D into square root of T divided by pi into rho. So this is the expression for the fundamental frequency. So already we know the standard expression for the fundamental frequency is F equal to 1 by 2L into root of T by mu. This also can be written as F equal to 1 by L into D into square root of T divided by pi into rho. So the ratios of the tension, density, length and diameters are given. So far I will write for F1. So this is the lower frequency. F1 is equal to, here every term is having the subscript 1. Okay, so F1 is equal to 1 by L1 D1 into root over tension T1 divided by pi rho 1. Similarly, F2 I will take. So F2 is equal to 1 divided by L2 into D2 into square root of T2 divided by pi into rho 2. So I will take the ratio F1 by F2. So the ratio F1 divided by F2 is now equal to. So first here I will write 1 by L1 D1, is it not? So that this will become L2 into D2 divided by L1 into D1. Okay, so I am dividing F1 by F2. So when I divide L1 D1 will be in the denominator, okay, and this L2 D2 will come to the numerator, like that into square root of, here T1 is in the numerator, so T2 will come to the denominator. So I can write it T1 by T2 into, so this one in the denominator pi rho 1 will come. So here pi rho 2, so this is pi into rho 2 divided by pi into rho 1. So this you can substitute and find out, is it not? You can divide or you can multiply by the reciprocals, so that this pi get cancelled. So now we get F1 by F2 is equal to L2 by L1 into D2 by D1 into square root of T1 by T2 into rho 2 by rho 1. That's all. This is the simplified format. because the ratios, length ratio, diameter ratio, tension ratio and density ratio are given here. So from this we have to attach the values, that's all. Okay, what is F1 by F2 also can be substituted. F1 is 350, F2 is 360. So I am going to substitute in this equation. So left hand side becomes what? 350 divided by 360. So this is equal to L2 by L1. Here L1 is to L2 is X is to Y. So L2 by L1 will be Y by X. So this will be equal to what? Y divided by X into D2 by D1. Here D1 by D2 is 4 is to 1. Therefore D2 by D1 is what? 1 is to 4. So this will become 1 divided by 4 into square root of T1 by T2 ratio. T1 by T2 is what? 8 is to 1. So here this is 8 by 1 into rho 2 by rho 1. So rho 2 by rho 1 is 2 is to 1. Okay. So this is 2 is to 1. So 2 by 1. Okay. Now this 0 and 0 will cut. So this is 35 divided by 36 on the left hand side. So this is equal to y by x into 1 by 4 into, inside the square root 8 into 2 is what? 16. What is the square root of 16 is 4. So into 4. So that this 4 and 4 also get cancelled. So y by x is equal to 35 by 36, is it not? So y by x is equal to 35 divided by 36. Therefore we need the ratio x by y is equal to what? 36 divided by 35. So this is the ratio of x is to y. So we get 36 divided by 35. So the option A itself is the correct answer, is it not? Therefore option A is the correct answer. So here what is required is the fundamental frequency has to be expressed in terms of density, okay, and diameter, density and diameter. So for that here actual mu definition is what? Mass per unit length. So I am adjusting the terms in terms of density and diameter. Otherwise the problem is very simple only. I hope you must have understood them fine.